Hey and welcome. In this video, we will discuss a very important topic today. That's outline. What are outliners, why they are important, and why to find it out. Methods that we're going to discuss today is z-score, IQR, box plot, and scatter plot. First of all, let's discuss why we need to find this outline. Guys, we have the null values in the data set, okay, and we want to fill this data. We have this data and we have two null values. If it's a numerical value, we use something called mu, that is average or mean. Or if it is a categorical value, we use mood for that. In any case, if we are using a mean value, the mean varies a lot if we have an outlier. I'll give you an example. Suppose I have a series of 2, 3, 4. I have two empty values in between, and the last value says 100. If I try to fill these two null values with the mean, that is average, you will know that it is not going to be a normal value because when I add 2, 3, 4, that's okay. The moment I add 100 to it and divide it by 4, the value is going to be very high. It might reach 25, which seems very high for this range. It may go even higher for this. Now, I have given a small example. You might hit 100 values and it affect accordingly. Higher the, or you can say the bigger the outliner is, more it is going to affect your project. You don't want to fill a wrong value in your null values. You are now having four or three outliners which were not even present before. Now your data is telling a different story completely. So that is why finding an outliner, detecting and solving it is very important. So first of all, let's discuss the z-score part. Z-score is a way of finding the outliner. It checks the number of standard deviation from the mean value of a reference population. In a generic level, it tells you how many values are away from the mean of the data. And far away they are from the mean, more chances we have that it's an outliner. And this is how we detect an outliner by z-score. You can see that x is my score minus mean is a mean, and I'm dividing it with standard deviation. That is the formula for z-score. Next, we have IQR, that is called interquartile range. Interquartile range is quite straightforward. We have Q1, Q2, and Q3 in data, which is dividing data into four equivalent parts: 25%, 25%, and 25%, and so on. So we have 25% division by these three Q1, Q2, and Q3 interquartile range. And interquartile range is dividing Q3 from Q1. When you subtract Q3 from Q1, that's your interquartile range. IQ describes the middle 50% of the value when ordered from the lowest to high. To find the interquartile range, you just need to find the median and the mid value, you can also call it, and of the lower and the upper half of the data. These values are Q1, Q2, and Q3, and Q3 is subtracted from Q1 to find the interquartile range for you. In the IQR, if you want to find the outliers, simple logic is that you have this data, you have this interquartile range, okay? We add 1.5 into IQR value to Q3 and Q1. You can see that I'm adding for Q3 and subtracting for Q1 because I'm changing the direction. For Q1, I'm going in this direction. For Q3, I'm going in this direction. Any value which is away from this value, you see this line, if it is even away from these margins that we have, that indicates these values are completely outliners and we should do something about it. We have around four outliners in this picture which are predicted by IQR. Same logic is used in our box plot. Box plot do the same exact thing. It has Q1, Q2, and Q3. We have these outliner, and this is how at the right side, this is how a box plot really looks like. We have these values as outliners, and we have this value as an outliner in the box plot. This is my IQR. This area is my center point. This line indicates my 50% quantile, and this is how it works. Now let me. Next is scatter plot. In the scatter plot, guys, when we have the plotting, we can easily spot that one value is away from the complete area. This value, these value, these value are away from the average. It is away, far away from the group that we are having. This is our group. And from the group, from the mean data, if a value is too far away, you can see in the picture, that means they are outliers. These values are outliers. And we always want to work on the outliers and we always want to remove that. So core thing is, as far away the data is from the average part, you can see the complete A group, they are outliers. These are the outliner and this is the group. I hope this logic is quite clear. Scatter plot is very easy to plot and very easily understood by these plots. Now, let's move forward and see how we do this in the coding part. In this sheet, we are detecting the outliners. We have scatter plot, box plot, z-score, and IQR. In the same data set, what I'm trying to do is finding or handling the outliners, and to do that, I have to detect it. So why not to handle null values before outliners? Because if you handle the null values before outliners, removal, it will affect the average value. You can see that guys, I am having this data and mean is 3.5. I'm having this data and its mean is 4.2, 42, sorry. Now 42 is a very big value for this data set, right? This is happening because this 200. So normally this data has average of 3.5, which will be used as a null value filler. But if you use it with an outliner, you will have 42. Means you will fill the null values with the wrong value, which will create more wrong values in the data set. And maybe later it is very hard to detect which is the wrong value that I have filled. Now we are filling the null values with this drop get dummies and we will get the result. Now, guys, one important thing. Let's not discuss the plot too much. Let's discuss the fair scatter plot directly. In the fair column, if I'm trying to predict an outliner, I can easily observe that I have this value, which is way too far away from the complete group. This is my group, and this is the distance that we are having. This indicates that this particular value is an outliner and it needed to be handled. Now, one thing to notice, guys, we are not really sure how many outliners do we have because when we have this value, is it is it going to be a single value, is it going to be a double value, or what? So how to predict that part, how to check that part? To do such thing, and to you can say to check if it is one or two, we can use normal mathematical operations too. We have given the alpha and we can check if it is transparent like this or it is visible. If it is visible, maybe there is a chance that it is overlapping two or three values. To check exactly how many values, we can simply use box plot and to check the values. Even if it is not clear in the box plot, it is overlapping completely, we can use simple Boolean indexing. X fair, giving X fair is greater than 300. That is the maximum limit that we had. And checking if any value is overstating this. As we can see, in the box plot, it is low, every value is below 300, and only these three values are coming which are more than 300. It simply indicates that this value is an outlier. Now, we can simply go ahead and fill this value with some value which we think is okay. Again, guys, I'm giving 300, but it's not like you have to give 300. You can give the maximum value, you can give the minimum value, you can also give the average value after removing the outliner, or maybe you just want to give an approximate value in this case. So just to make it bigger from the group, why I filled 300 here, as I was observing, I noticed that the data is not more than 300. It is even below 300. If you be checked exactly, it is somewhere 280 or something. So what I thought, if a value is too high, rather than putting it here, let's put it here. Okay. So if the value is too high, I put it little next to the highest value. So the value was these three people have paid very high, huge amount. That information not losing, and still they are close to the data set. So they are not completely outliners of big outliner values, yet they are close to the data set. So it gives me a clarity that okay, this will not affect my data set too much. when I put this value. Now, moving forward, in the age also, I'm checking if there is any outlier by using the scatter plot only. I can do the same thing by using the age plot of a box plot, and this is what I'm getting, that people are above from 80 years, which are outliners, which can be handled. Now, again, handling this and not handling this is completely on our choice. We only have one value which is above 75. Okay. Now, let's see the z-score part. Z-score basically take the value, subtract it from the average, and divide it with the standard deviation. To find average, we simply use mean. Age dot mean and fair dot mean. I have these mean values. I am finding age dot standard deviation, fair dot standard deviation. I am creating a lambda function which do a simple thing for age and fair both. What it does, it subtract the value from the age mean divided by standard deviation, which is the formula basically, and I'm putting the value. Now I have just taken the age column and applied it to on the complete column. I'm getting these values for the z score. Now for this, I have taken the mean too, and for this I'm checking the maximum value too. Now I'm just picking which value has this highest value. It is giving the same index as above, and I can say okay, the highest z score value is an outliner here. Now, if we go on the fair part, same thing again, apply the fair z-score. I'm getting this maximum value. I'm getting the argmax, which means the index of this. I'm getting this value. So these two are my highest value, which I don't want to remove. I have also used enlarge with heap, and I'm filtering out all the values which are big, and you can see that it's most heavy or most highest value, three values are detected. As we have already noticed, we have three outliners, so we are taking the three values, top values. Okay, and I can also use plot and the top three values, and this is the index of these three values. This is how you find the outliner in a data set. If you want to use IQR by this method, you can simply use the formula and put the value here. I have this data, and I'm going to append an outliner here. I have inserted 0 in at the position. I'm inserting 2 at the 0 position. I have this value. Now what I'm doing, guys, I have given an outliner at the negative side and the plus side. Again, the negative side outliner is not a big deal. So what I'm doing, I'm picking a percentile of 25, 50, and 75. To find my IQR, I'm just doing Q3 minus Q1. It will give me the IQR value of 12. I'm picking Q1, subtracting IQR into 1.5. Okay, that's the lower range, and this is my upper range. Q3 plus IQR into 1.5. Now, what I did, lower range is this, upper range is this. I will be using this to filter out all the outliners. So, any value in the data that is below the lower range, okay, I want to print that value. Any value which is above the lower upper range, I want to print that value. As you can see, it is easily filtering out the 2 and 200 for me in the dataset. A very powerful and easy way of doing it. You can use it as a formula directly, and you can work on it completely, and you get all the outliners filtered out. And after this, you can easily use argmax to check the index of this and just eliminate this value and replace it with something which you think is okay. You can also directly replace this by using a replace method in pandas and with a value which is perfect. So that is all for the video, guys. Thanks for watching the video. I hope it was useful. Thank you.